Hello everyone, welcome to the NN Classroom. Today I'd like to share with you a classical past paper question asking for bonding and structure topic 4 concept in 2018 time zone 1 May paper. Question number 11. Let's see which metal, so given, has the strongest metallic bond. So the given situation is choosing the one with the greatest, strongest metallic bond. So here comes with a really classic testing point in the foundation of what's the factors affecting a bond strength, in this case metallic bond. So do record the definition first. What's metallic bond? Remember, metallic bond is the electrostatic attraction between the metallic ions, I simply use the symbol, and also the delocalized electron, a sea of delocalized electrons. So that means this here comes the attraction between something positive, which is the metallic ions, after they lose the electrons, and also finally the ions with the sea of delocalized electrons, right? So this non-directional nature of the electrostatic attraction will be what we call metallic bond, right? But not a lot of people know the definition, but not a lot of people will know what are the factors affecting the strength. So now it tells you, right? Remember, when talking about metallic bond, here comes two major factors of criteria to look for the factors that are affecting the strength. The first one is simply called charge. That's so easy understandable, right? Because the higher the charge of the metallic ion, it will comes with a stronger attraction with the electrons, right? So imagine if I'm having a +1 charge state towards the delocalized electron versus a +2 charge state towards the electrons. Obviously, +2 charge state will having a stronger attraction with the outermost of delocalized electrons, right? So that's why the charge higher the better. Higher the better. That makes sense, right? So because of this perspective, you can already see that what they are different in terms of the group number. Sodium in group 1, magnesium and calcium in group 2, while aluminium is in group 3. So really high chance already for aluminium to be the winner, right? So but let's look at the second point. What's the second point? Is actually what we call the size. In this case, the size is talking about referring to the concept of ionic radius. Why? Because you can imagine, right? If the iron is going to be smaller in size, right? Smaller size of iron, maybe I can draw it out. That seems like to be easier to be interpreted versus bigger ions. Assume they have the same charge to be fair. Smaller size of the iron, is it going to be having a stronger attraction, right? Somehow, because smaller you are, the distance that you can attract those electrons towards your space is going to be shorter. While if the ion is going to be bigger, somehow, no matter how strong you pull the electron towards yourself, still there's some distance that's separating the center of your nucleus with the delocalized electrons, right? So that explains why the smaller the radius, the stronger the metallic bond, right? Shorter, the better, right? Obviously, some students may recognize that this is something what we call the charge density. Exactly is the points that we use to explain the strength of ionic bond as well. So if you know what I'm saying, so congratulations, right? So what I'm wanting to deliver the message is that, in fact, the strength of metallic bond and the strength of ionic bond actually shares really similar concepts, that having both the factors of charge and size to explain the strength, right? So in this case particularly, if we are having smaller ions, better in terms of attraction, higher charge, better in terms of attraction, right? So that explains why we better choose the size of the ion that is the smallest and having the charge that is the greatest after delivering or removing the outermost shell electrons, right? So obviously, as you have recognized from the predict table, the first three are within the same period. That means the ions is going to be roughly similar size versus calcium, which is much bigger. So that's why calcium not our choice in terms of the factor of size. And so finally, in terms of the factor of charge, we kind of conclude that aluminium is the best, right? Because aluminium you get plus free charge after donating the outermost shell electrons, while magnesium only 2, sodium only 1, right? So because of the group number offers how they would be stable, right? So eventually my best choice will be C.